Welcome to NCIX Tech Tips. Today we're going to be talking about some upcoming technologies from AMD, and I have a special guest with me here today. This is Jim Bovenzi, and maybe he can explain a little bit what his role at AMD is and what we're going to be talking about today.
Well, thank you for letting me be here today. It's very nice to be part of the show. I am Jim Bovenzi. I'm a field applications engineer from AMD, and perhaps I can explain some of our upcoming architectural changes in the Bulldozer module, and hopefully your audience will be interested in it.
I think they will. Stay tuned for more. The first topic we're going to touch on today is the Bulldozer module. So what this is it is a building block of many of AMD's upcoming processors, and I want Jim to sort of touch on the more technical aspects of what this means for processor design from AMD in the coming years.
Well, thanks. The Bulldozer architecture is a new architecture that's represented behind me on the slide. It's our first change since the Opteron was introduced in 2003. We've redesigned the core itself into a module architecture that consists of two cores, Core 1, Core 2, and shared resources amongst the cores, but dedicated resources in there. So you'll have integer performance for each of the cores and a shared floating point, plus shared L2 cache and shared L3 cache. This module will allow us to ramp up future designs and to increase core count with efficiency and architectural changes in our products, starting from the server and coming down to the client and maybe even the mobile space.
So basically what AMD's done then is they've taken a single core CPU and they've made it, instead of just being a traditional core, which would be one of those integer units and one floating point unit, and they've made it almost like a core and a half, because there's two integer units, one floating point unit, some shared resources, and now we can take these and we can glue them together, and there will be more on that in just a moment, but we can squeeze vastly improved performance out of what is a single core, which could be as much as almost double performance in integer limited applications. So this could be very, very exciting then.
I agree. If you have a single-threaded application, you would have one of the cores acting on that. Let's say, for instance, you wanted to put more resources on that core. You would take the other performance, the other part of the core, and add it to the original one, thus increasing the throughput and performance on the original core.
Outstanding. Now, because this is the first complete core redesign from AMD in 8 years, we're going to see a lot of innovations that are designed not only for today, but also for the future. Because remember, Opteron had to last this long and stay competitive in an ever-changing marketplace. So I want to talk a lot about the efficiency and the modularity of this design. So the first thing I'm going to let Jim talk about is what AMD is doing specifically for power efficiency.
And that's a very good point, because as you've had shared resources in the past, or a core that's been kind of slightly up or in idle state, you still have some power consumed. With the new Bulldozer module, you can actually turn off a core completely, as in down to zero. Thus your efficiency goes up quite a bit, saving on power and your workload. And as the cores need to be ramped up, they can be turned back on and placed in the processing stream. Absolutely.
Well, that's outstanding, because as we know, a lot of the time you're sitting at your computer browsing the internet, and the last thing you need is an 8 or even a 12-core CPU running on all 12 cores. It's kind of like a hybrid car almost. It's going to turn off the parts it doesn't need. Now I want to talk about die efficiency, because processors are getting more and more complex to design every time. Every time we do a refresh in these products, we have to find a way to make it so that we can make better use of that high-tech manufacturing space that we're using. So I want you to talk a little bit about why the design of the modular core makes sense from a die efficiency standpoint.
Well, it makes sense because, again, you have this module consisting of all the resources that you need within that module, the floating point element, the integer element, the L2 caches and things, but the L1 cache, excuse me. L2 cache is external to it. And you have that architecture that you can kind of stamp out and cookie cut amongst the die, and so as the die nanometer topology shrinks, you can get more and more of these modules on one piece of silicon.
So basically what that allows AMD to do is, and this again comes down to the efficiency and the modularity of this design, is as we're able to take 8 cores, and let's say right now we're able to manufacture them at this size, and let's say with a process shrink we're able to manufacture them at this size. Now, without doing really a huge amount of additional engineering, we could just sort of tack on more cores here, and now all of a sudden we have far more horsepower to throw at whatever problem we're trying to solve with our processor. So now let's have a look at Bobcat, which is kind of a little brother to Bulldozer in some respects, but is also slightly different. In fact, it even comes with a new name. It's called an APU. So maybe you can explain what exactly is an APU.
Sure. An APU stands for Accelerated Processing Unit. So if AMD has re-architectured this from using the Bobcat modularity approach, if you have a CPU element, a processing element, and a GPU element, a graphics processing element, we had to come up with a new name, a new term for that, so we call it APU. So you'll be starting to hear about that more in the public, an APU. And it is a modular approach, kind of like Bulldozer, but on a smaller level. Bobcat is going to be meant from kind of a ground up, an embedded level, a netbook, notebook, thin client kind of level coming from the bottom up. And it'll eventually enter the mainstream as a desktop component.
Now, you mentioned that it's like Bulldozer in its modularity. So does that mean that the engineering team at AMD can just kind of copy-paste Bobcat cores the way they can with a Bulldozer to make it bigger or smaller?
Well, you would think that, but it's not necessarily the same architecture, although it does have some of the comparisons from Bulldozer. All of our technology starts from the top. The server level, we put the more complex process in that level, the architectural design, and that filters and trickles down to the desktop and eventually the entry-level products. So in a way it does, but in a way it's a brand new architecture from kind of the bottom up.
Terrific. Okay, well there's one thing that I wanted to sort of comment on, and you may not be able to give me as much information about this as I would hope, but the APU has, you mentioned a graphics component. Now, my understanding of a graphics component is that it's typically very strong for floating point operations. Is that correct?
Absolutely.
Okay, and one other thing that I did observe about Bulldozer is that AMD has really beefed up the integer power of that architecture. They've doubled it over anything they've done in the past on a per-core basis. So while I understand that this would be maybe potentially commenting on unreleased products, is there any hope for us that an APU-like design could come to the desktop where we can use some of that GPU floating point power to augment the integer powerhouse that is the upcoming Bulldozer?
That's good reasoning. Let me comment as much as I can on that.
Okay.
Think of it this way. If a CPU has traditionally been very strong in a serial processing realm, one task behind the other, and a GPU has been strong at a parallel architecture, taking an entire screen and processing all those bits and pixels at once, if you can marry the best of both architectures in one package, I think you've got something. And that's it. And the way AMD is leaning toward that is because of our merger with ATI, we can take the best of both worlds and bring this to a myriad of spaces from top to middle to bottom to give everybody what they need in the architecture. And as some companies take advantage of more graphic power or processing power, then that's included. You know, future operating systems actually have this built in to do GPU acceleration just in their operating system, and you'll be seeing that soon.
Outstanding. I think it's going to be an exciting couple of years. Thank you very much for coming on the show, and I hope you guys have enjoyed a slightly different flavor of NCIX Tech Tips today.
Thank you.